This Polaroid high print is different because it prints via dye sublimation. That's the same system as on my Canon selfie photo printer that I've used for years. In the past, whenever I wanted to print a photo out for friends or family, I'd use this printer, and in my opinion the results are indistinguishable from a professionally produced print. There are no liquid inks to dry out or to block nozzles up. In fact, the last time I printed a photo on this, before today, was about a year ago, so I took it out of the drawer.
Not these ones. These ones actually only have about, well, they're connected across the mains with a diode. So these ones will probably, they're only going to see about peak mains rectified volts, about 330-ish volts in the UK. But it's a dual multiplier, and basically what happens here is that there's a positive multiplier and a negative multiplier, and it's an easy, simple way. Instead of using one long multiplier to get up to the voltage, they use two. It's a common enough technique, and it creates the high voltage. What actually happens here is that when live is positive, or I should say live is negative, and the neutral is positive, current flows through the diode and charges this capacitor up to about 330 volts. When the polarity changes and this then live then goes positive and this goes negative, then the end of this capacitor is now connected to ground, it's negative, and the positive voltage here pushes the capacitor. The capacitor actually rides up on it, so you end up with the peak mains voltage of about 330 volts, plus what was on that capacitor, which is another 330 volts, pushed through that diode and onto this one, and you'll end up with about 600 or 700 volts on this diode. Just under, it worked out with the two added together, it worked out 1.334 kilovolts. And to get that, I actually had the circuit live and poked across it with the meter, but only across one side at a time, because the meter is only rated for about 1000 volts. But it's an interesting approach, but there's not any real good isolation, because this can go in any way round. And if you touch the grid in the front, which is just, you just pull this plastic grill off and it's exposed, then the only thing between you effectively and the range is two diodes. So, not necessarily very safe, but then again, yeah, not necessarily very safe at all, particularly given the strange, cheapy components. I mean, they've gone to the expense of building this plastic moulding with all the metal frames put in it. It just seems a shame they've kind of used this motley selection of random capacitors. But here we go. I'll put this over here in case you want to try and reverse engineer it yourself. So it's one 220 nanofarad, four 100 nanofarad capacitors. That's these ones, the exploding ones, and four diodes, which I'm guessing, I'm not really looked at that. I'm guessing they're 1N4007. If I can actually see through all this soot now. Yeah, I'd make a wild guess that they're that, but you just never know given the ratings of these capacitors. That one is most certainly not rated for 630 volts. I shouldn't think at 100 nanofarad. It's very odd indeed, but quite amusing, I have to say. I've featured this little bug zapper style device before in this channel. And I bought some more because I wanted to do an experiment. I wanted to put different coloured LEDs in them and try them outside and see which ones attracted the most insects. However, I noticed that these new ones have the surface mount LEDs instead of the standard 5mm type. Now, the last one, when I shorted it out a few times, it suddenly went bang. So let's see if we can make this one go bang. No, it seems alright. Okay. Now, I've already tested the power consumption. This one is 1 watt, about 4 milliamps. So let's put the def adapter to the side. The instructions are pretty much the same as the other one. They're just weird. It says things like, this go out as safe energy mosquito utensil is adornment, hypnotic quiet, Ceruo lighting designer, so must eschew lighting strobe lights usage whether then right direct effect go out mosquito effect. It's very odd language. It's kind of like multiple translations from different languages that have gone wrong. I should short this out before I, yeah, that holds a charge. That's worth mentioning. charge. So let's pop the lid in this and see if the circuitry is the same as before. The previous one, the circuitry was just grossly underrated capacitors. It was like, no wonder it actually went bang. And it was quite a modest number of voltage multiplier stages. Strange circuitry indeed in that, so it took me a while to trace it out. I wonder if it's going to be just the same again. I wonder if it's going to be the same random selection of capacitors of all different colours. Yeah, I'll do it. Right here. So there's the circuit board with LEDs. Okay. Right, I see what they're doing. Right. So let's, this is got nothing on it. It's got a resistor here. Big resistor. 56k, green, blue, orange. 5, 6 and 3 zeros. It's got 2 diodes, which is probably, it looks, just looking at this at the moment, it looks as though it could be a single stage multiplier. By the fact it's a small capacitor, a large capacitor. I wonder what's feeding the LEDs. Is that resistor doing the LEDs? Let's get the notepad in there. So, nice of them to use all the same colour for just about everything. So we've got the power coming in, goes up to, so these two are common, so the LED and the small capacitor. Let's get the LEDs out of the way first because their circuitry looks independent. So yeah, this is a one connection end here, that's the other. So let's get the LEDs out of the way first. The LEDs appear to be a resistor and then 2 inverse parallel groups of LEDs. Very simple. So in each half wave, one group lights, and it just makes it super simple. The only difference the other one had that I don't think this one does have, no it doesn't, was they had it tied across like that. So the voltage, the reverse voltage was always capped to exactly 3 volts across each LED by the other LED in the opposite direction. Rightio. So just out of interest, is that what's drawing most of the current? The resistor is 56k. Quick bit of maths. I equals V over R, so that's 240 volts divided by 56k equals, well, there's the current. It's about 4 milliamps. So that's, basically speaking, that's across live and neutral, or hot and returning, as it may be in your other part of the country, part of the world. Now, take a look at the rest of the circuitry. We've got the big capacitor. It's connected to, let's do the bottom here. So it's connected to, well, this would, in our supply, this would be live. Well, it depends which way it's plugged in, doesn't really matter. So I'll just mark it live. And it's connected with the 2 diodes across it. So big capacitor and the 2 diodes across it, which kind of points at a voltage multiplier arrangement. The neutral is going to the middle of those capacitors. So it's in a configuration like this. The diodes are pointing down the way, like that. It doesn't really matter which way they're going to go. The capacitors are rated (470 nano) at, well, that's an X2, it's 275 volt AC, which generally speaking these capacitors are rated for about 600 volts or so. The smaller one is rated, it's quite small, needs text in that one, 220 nano, and it's also an X2. So these are both suppression capacitors, that's quite good. So that's 220 nano, he said, botching that bit, and that again is 275 volt AC because it is X2. And the output output of the output to the grid is just across that capacitor. So this capacitor here, I kind of watch that now, like, I'm going to have to draw it like that, is going to the grid. That's very simple. It's just it's two distinct sections of circuitry. You've got the resistor here is feeding the LEDs, the little LED circuit board, and the two capacitors and the two diodes down there are the voltage multiplier. Very, very simple circuitry indeed. Very clear, well-spaced circuit board. That is infinitely better than the other one. It was very poppy, very sparky as well. It's got quite a lot of beef behind it. So yes, that's a better design than the other one. It should be more reliable. It's one that I wouldn't actually be too bothered about leaving plugged in. The other one I would have to add warmth, or it's just purely as a cheap option just to make it simple. I mean, a resistor in series LEDs is about as simple as you get, and this is a very cheap unit. It's pretty neat. It's pretty neat. And it's quite a nice layout as well. The way it goes together. That little circuit board. Yeah, it's not too bad. It can't be slide too far. It's not too close to the connection. And these connections, it's not actually being shorted against the interesting little design. These are better than the last one, but still, it's got that thing that, it would have been nice if it took the standard 5mm. But don't worry, I can fix that. So yes, that's interesting little unit. I've added a few extra details to this video. The first is that this particular unit came from eBay seller called my_holiday store. And it cost £1.36. Very cheap. I mean, they're all very cheap. It's a very common item. The stand the whole LED, so I'm saying what you're going to get here. It's notable that this particular version has the rather odd number H666 on the front of it. Right. The circuitry inside, let's take a look at the voltage multiplier again. So here is the large capacitor, and here's the small capacitor. And the way the voltage multiplier works is the DC power that's coming in our case, it's 240 volts. That is 240. It's an alternating polarity, so live and neutral are going, positive. The live's going positive, and then negative, and neutral's going opposite. So when turn the diode around, which way the diode's pointing, and when live goes this